Hi everyone, welcome to Lab 6. This is our last lab, and today we're gonna talk about timer design, which we're gonna build a timer to keep a LED light keep it on for a while, and after maybe 10 seconds or 5 seconds, it will automatically go off. So yeah, the timer is the key part. So we're gonna see the timer first. Okay, there's our timer. There are, you can see here, 4 inputs and 1 output. So let's talk about the 2 input CNT initial and CNT rest. So the thing is, for CNT initial, we're setting a 8 binary number to be started with. Okay, which means we can start in counting, for example, 1 0 0 0 0 0, and we set our counter. We will restart RFT to be any number bigger than the say counter initial. Okay, maybe you can say like 1 1 1 1 1. So we have a clock here, and we'll have another input I will talk about later. Let's assume it works right now. So which means that initial counter will counting from 1 0 0 0 0 to 1 0 0 0 0 0 1, and so on and so forth. Okay, until it comes to our destination, which is our counter restart 1 1 1 1 1 1 1, and at this time the counter done the counting. Okay, so the output here, well, it is still counting. Output here timer, it will keep going. Output 1. Okay, so the reset is actually for once we done, once we have there's nothing here. It's like a control for a whole of the timer. If there's nothing here, we don't need to count anything. If I give a signal, maybe 0 or 1, so let's say maybe it's 1, so the whole timer start to work. Okay, then let's talk about how we gonna uh, customize the time for a timer. So one thing is we need to know the clock frequency, and we need to know how many ticks, how many bets, the best difference between the count initial and count restart. And you do rest math. You can, this is part of our question in for this lab. So I won't go talk about detail, but I think you'll get idea. If we know the total difference, total time ticks, and we know the frequency, I think we can get the time, right? Okay, and this is the whole design for our timer. We have a finite state machine. You can see here we have 3 states: start, off, and on. So one start, actually we come to off just every time we start with off, right? So no one touch the button, the input, the button. I mean to start a LED light. So we don't touch it. So it's off, and the reset state is 1, and the light output is 0. Nothing happens. To keep in this loop. Once we touch the button once, a button 1, we shift from off to start state. In the start state, we have a reset become 0, and the light is 0. And this time is like a starting state. And then automatically from start, it have to be shifted to the on state, which is a reset is 0 and light is 1, which means we can see the LED lights keep on. And still, and this moment in here, the timer starts to work. If a timer don't tell you to stop, it will keep in this loop. And when the timer become 1, which means is I'm done, then I can go to off state, return to off state, and keep in here. Okay, I think you can based on this finite state machine to do most part in design. Let's see the code. Oh yeah, this wholly design, the whole design for this problem here. You can see here we have controller, we have timer, and we have input button. And but in here we didn't save output here because I think we have a light output here. But this is pretty much like our whole design. Okay, and this is our code. Okay, let's see. So this is our top module here. I mean, module label array. I have input, the B, which is the input button, and clock and output. And also we have timer and reset. So okay, let's see here. So we always assume our initial counter is from this much with all zero here, and we use hex, which is to be simplified, but you can use binary, or that doesn't matter. So you need to think about, let's say for 10 second hertz, 25 mega, 10 seconds, 25 megahertz internal clock, what value should put here? Okay, should be a restart value. And also according to a finite state machine I showed you, you can write in a code using something like if else condition to finish this part. Okay, and this is our controller part, and the rest of them is timer. So we want to simplify this part because you don't need to do anything, but you need to just simply just like add all the module into the timer, and you should be fine. You don't need to do anything with the code in the timer. Okay, the only thing you need to do is here and here. Okay, but I will go talk about the timer a little bit. You can see here in timer we have a different set of modules. We have something called comparer, a comparator, and adder. I think pretty much like lab 5 we did. And the thing is like just like once we give input here, we let those things input those things here. We keep adding and compare whatever after I'm adding one. Compare the result to this one and to decide whether if it's bigger than this one or equal than this one, I just output timer to be 0, or if 1 to mean to stop. Okay. So yeah, let's do actually the code in our projector. You can see right here, this is some hierarchy here. So you can see a laser, timer with adder and a floper, a two-man part. And for adder here, we have negative value and full adder and a comparator. So yeah, you just need to writing the right code right here and apply those module, copy the code, and make a lot module and make it in the right hierarchy, and writing take your own test bench, and you're done. Thank you. Okay, this is a demo for Lab 6, lever ferry system, which is a timer for the LED lights. So once we click a button here, the lights will keep on for a while. The length is the time I set in the code, and after, yeah, then it goes off. And if you do it again, it's counting, and after a couple seconds, it just it went off. That's it.